Okay, so finishing up this lesson, and this is sort of this is the big part of the unit, is proving identities. Using all those identities that I gave you, the ones that we've already discussed about. Okay, so basically like I said, you're going to be given an expression on the left, an expression on the right, and somehow you have to manipulate one or both of them so that they equal each other. And then you've proven that they're the same. Okay? Here's some hints. When you start with an inequality, generally start with the more difficult side. Because that's the one you're going to be able to simplify. Okay? If you get stuck, work on the other side. See if maybe that helps. This one's really important. Change everything to sine and cosine. Write it all in terms of sine and cosine. Don't use tan, don't use the reciprocal ones. Okay, if you do that, they're generally easier to prove. Whenever we have fractions, like we did some examples before in this lesson, okay, always combine them. Like especially if you have to add them, look for common denominators. And then we talked about different things you can do to each side. You can combine fractions by adding or subtracting or multiplying or dividing. You can try factoring. You can try multiplying out if something's being squared. And very last resort, if you're stuck, try that conjugate. But like I said, that doesn't appear very often. And here's how we structure them. Okay? So they all look like this. You're given an equation. So I'm going to do left side, right side. And I've got cotangent x plus tangent x. I need to see if that's the same thing as cosecant x times secant x. So I've got to start working on both sides, or either side. This is probably considered the harder side. There's not a huge difference between the two, but let's do this. How can I write this in terms of sine and cos? Cotangent is always not tan. I want sine or cos. Cos over sine. And sine over cos. Get the axis. Okay, so I've got them in terms of sine and cos, but I've got two fractions. I want to add them together. What's the lowest common denominator? Sine x cos x. What do I have to multiply this fraction by to get this? Cos x, right? So cos x times cos x is cos squared x. This one I have to multiply top and bottom by sine x. Sine x times sine x is sine squared x. So I've got it into a single fraction. Can you see any further simplifying I can do? Okay, I'm going to just going to write what I did there. Just in case when you look back on it, you're not sure. I have to multiply like that. Anything?
One.
Yeah. That's the main Pythagorean identity. That's 1. So I get 1 sine x cos x. I can't go any further. So somehow I have to make the right-hand side look like this. Well, what's cosecant x? 1 over sine x. And what's secant x? 1 over cos x. And when I multiply those two together, I get 1 over sine x cos x. Got it. Okay. It's like a puzzle. These things can be frustrating, but I find that when students get them, it's probably the most successful they feel they've ever been at math when they get one of these. Okay, this next one looks pretty involved, but so I've got cosecant squared theta plus secant squared theta over cosecant theta times secant theta. And then here, I've got cotangent theta plus tan theta. Well, we already did that one, didn't we? We did that one here. So it's the same. So let's save a little bit of time. And let's say, well, we've already done this one. We made it into cos x over cos theta over sine theta over cos theta, combined the two together, and found that we got 1 sine theta cos theta. Same one. But this left-hand side is going to take a little bit of work. We have a big fraction. This 1 over sine squared theta plus this 1 over cos squared theta. And while we did the bottom one here, over here, it's 1 over sine theta times 1 over cos theta. Okay, big fraction. I got to add these two into a single fraction. What's the lowest common denominator? Sine squared theta, cos squared theta. And then I would multiply this one by cos squared theta over cos squared theta. And I'd multiply this one by sine squared theta over sine squared theta. So when I do that, I get cos squared theta plus sine squared theta. What about the bottom? 1 over sine theta cos theta, right? I'm running out of space. Okay. I got to divide this fraction by this fraction, which means I got to take this fraction times the reciprocal of this. Before I do that, do you notice anything in this fraction or anything in this fraction that I could simplify? Yeah, this is 1. So when I change it to multiplication, I get 1 over sine squared theta cos squared theta times the flip of this, sine theta cos theta over 1. Oh, I'm so close. I've got to make it look like this. I'm very close. Can't I take a sine theta out of each? And then divide a cos theta out of each? Or take a sine theta cos theta out of each? So what am I left with when I do that? 1 over sine theta cos theta. Got it. Left side equals right side. Any questions so far? Okay. This will come with practice. Okay. It needs practice. Okay, this next one. Left side, right side. Clearly the right side is the more difficult one in this. Yep.
In the last one, like,
Yep.
I think we just simplify the entire, like, thing at the top. It's like the sign greater.
This one?
No. Where you said 1 up on the top, it was like on the.
This one? Yeah, simplified too.
You know where you surface today?
Yes.
Beneath that.
Can I just simplify this to 1? Or this one to 1? I can't simplify this one to 1. Okay, then I need 1 at a time. Because I'm hearing you and you and you. Go.
They explained it to me, because there's no plus.
Way to go, guys. Good job. Don't shake your head. That's all you do. You come in here and you're like, shake your head. And then you tell me a story. And then you leave shaking your head. See, look at you. Okay. Let's work on this side. Remember, if there's more than one term, you got to treat it like there's parentheses around them. You can't separate them. They got to stay together. So I've got 2 fractions I'm adding together. I need a common denominator. What is the lowest common denominator of this and this?
just the multiplication of the two, right? This times this. What do I have to multiply this by to get this? Sine x over sine x. So I get sine squared x. What do I have to multiply this by? 1 plus cos x over 1 plus cos x.
Okay,
I'm going to do 4 multiplications here, right? So 1 times 1, 1 times cos x, plus cos x times 1, plus cos x times cos x, cos squared x.
kicked into the other side there.
Well, I can do some simplifying here. Sine squared x plus 1 plus 2 cos x plus cos squared x. I can combine the 2 cos x's. I don't need the parentheses there. Where do I go now?
Because I'm going to have to really condense this down to make it look like this. Sorry?
Yeah. This and this make 1. So what do I have now? I have 1 plus 1 plus 2 cos x. Or in other words, 2 plus 2 cos x.
Notice, like, we can't do anything to the bottom, but anything up top? If you look at the previous page, I mean, we've combined any fractions. We can't do any fractions. We've multiplied things out. What else do we try? Conjugate won't work unless there's just this on the bottom. But good thought. There's one other word in there. I heard it. Factor.
Can I factor this?
Isn't that a GCF?
So I can take a 2 out of both of them, right? What's 2 divided 2? Plus 2 cos x divided 2. Oh, baby. Oh, yeah.
Anything now?
You can cross out the 1 plus cos x's because this is being multiplied, this is being multiplied, those can go. So you're left with 2 over sine x. That's as simple as you can go.
So you got to make the left-hand side look like 2 over sine x.
So there's only one step to do, isn't there? Isn't this 1 over sine x? So this one's 2 over sine x. Left side equals right side.
Okay. Again, it's like a puzzle. But if you follow, get everything in terms of sine and cos, get the fractions together by adding, subtracting, multiplying, dividing. If you're stuck, look for factoring, look for conjugate. Okay. So the last example we're going to look at. A lot of room here. Sine theta is 1 minus cos theta, and remember, just remind myself that those have to stay together. So those. Well, there's no fractions to add or subtract or multiply or divide. There's no factoring that can go on. Remember, this is equals between here. Don't get the temptation to cancel. I've run out of options. Conjugate. So we have to multiply this side by 1 plus cos theta. 1 plus cos theta. Because remember, when you use the conjugate, use it on a denominator, not a numerator. We always use a conjugate on a denominator. Okay, so if I multiply this, I get sine theta plus sine theta cos theta. And on the bottom, I got to do 4 multiplications, so I get 1. 1 times cos theta is plus cos theta. Minus cos theta times 1 is minus cos theta. And minus cos theta times minus cos theta is minus cos squared theta. Sorry? I'm right, aren't I?
Yes.
Yeah. Those cancel. So I'm left on the bottom with 1 minus cos squared theta. Back to the top? Back to the bottom?
No, the bottom.
The bottom is what?
Uh,
Good, yeah. And factor the top. So really, I probably shouldn't have multiplied it through to begin with, because when I factor it, I'm going to get back to where I was before. What now? I can take a sine theta out of each one and be left with sine theta, which is the right-hand side. Okay. Like I said, that one, it's very rare that you see it, but I just want to make you aware of it. The previous 3 are the more common ones. Okay. The left side equals right. So, at the very least, for Monday, well, it's pretty much the entire exercise. Let's just say exercise 6.1. And if you're under a time crunch, at least do some of those proofs so that you start to get comfortable with them. Okay? Because like I said, that's going to be a big part of this. Because the next step is we're going to introduce a few more identities. And it does look a little overwhelming at first, but remember you have the formulas for most of them. Okay? And if you do things in sort of a systematic order, it makes things a little easier.